Now let's find normal unit vectors to this line x cubed. So in the previous videos, we found two lines, a tangent line and a normal line. But now we want to find these unit normal vectors. So these are vectors with a magnitude of 1 that are normal to a line x cubed at this particular point 2. And again, one of the things I mentioned in the last video, one of the applications for this in electromagnetics is different boundary conditions problems. So that might be if you had a material 1 on this side, material 2 on this side, they're separated, or there's a boundary between them that could be described by a function. You may need to know what a unit normal vector is at a particular point in order to determine the electric and magnetic fields at that particular point. So we're going to find unit normal vectors in this video. So the first thing that we do is we find a vector using the 2 points on the normal line, and you can find this in ULAB 3-1.3. That's our class textbook under the distance vector section. And then we could take that vector that we found and normalize it to get a normal unit vector. And you can see that in 3-1 in the basic laws of vectors. So basically what we're doing is if we had two different points, right, these two, we could find some vector r12 between 2 points by applying this formula from P1 to P2. So we can find a vector from P1 to P2. That's essentially what we're going to be doing in this video. We want to find a vector from here to some point, any point on this line, and a vector from some point to another. We can say this is a normal vector, and then we can normalize it, turn it into the unit vector to get the normalized unit vector. And so what we're going to be doing is basically finding a vector like this r12. So let's choose a couple points. So choose point 1, and we're going to choose that point that we've chosen for all of our other parts, which is when x is equal to 2, f of x is equal to 8, and then we just need to choose some other point here. Now, for my example, I just chose x is equal to 3. So you could choose any x along that line, but I just chose x is equal to 3. And then I substitute x is equal to 3 into the normal line. So the normal line is what we found in the previous video. And when I substitute that in, I get a y value, and this should say 95. I get this y value. So now I have point 1 and point 2. So that's a point here. And then I also found a point here. And that point, it's going to happen to be very close to the tip of that normalized unit vector, but it's also going to be what we use to find a general normal vector. And I can use those 2 points now in these equations from ULAB. So finding a vector from point 1 to point 2. So that normal vector, the x direction will be x2 minus x1, and in the y direction will be y2 minus y1. Now, this point 2 contains x2 and y2, whereas point 1, this has x1 and y1. So I will substitute these in. So 2, 2, 8, 8, and so on to get a normal unit vector. Now, to normalize it, I take the magnitude using the root of the sum of the squares, and it turns out that the normalized the distance of that vector, it's nearly 1 exactly, which you could kind of guess or by taking a look at this point at x is equal to 3. It's almost 1, and that's just because the slope of the normal line in this particular example problem is just minus 1/12, so it doesn't change that much. And that's why it's so close to being 1. Now, when I do that, I get a normal unit vector by performing the normalization, just like we see in our textbook or any textbook. And so we can get a normal unit vector that has this x value and this y value. Now, there's another normal to this line, and that would be the minus n hat. And by doing that, I could just multiply it by the negative number, and that would give me vector in the exact opposite direction, which would also be normal to this red tangent line that's kind of overlaid on our function line, which is up there. When you're performing boundary value problems, like you do in this class or in other electromagnetics classes, the difference between a positive and negative is often just going to be based on whatever your particular reference is. And we'll talk about that more later in the class, but for now, it's enough to just see how to find a normal unit vector. So thank you, and I will see you in the next video.